Hey there! In this tutorial, you're going to learn how to use AI to convert text into speech using the Zonos TTS app, which, by the way, was recently introduced with amazing quality. I'll show you step by step how to easily install it on your Windows system and how to create professional-grade audio at the highest quality. So, let's go check out a few sample voices generated using this TTS model. Wow, I can't believe this is actually happening. Ha 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 ha! We finally made it. It's like all the stars aligned just for this moment. I wish I could freeze time and live in this feeling forever. This is truly one of the happiest days of my life.
I don't know what to do anymore. It feels like I'm stuck in an endless loop of disappointment. I wish I could go back to a time when everything felt okay, but now, I'm not even sure if that was ever real.
Are you serious right now? After everything I've done, this is what I get. I've worked so hard, and yet here I am, being treated like I don't even matter. It's so frustrating.
Wait, no way. I must be dreaming. There's absolutely no way this is real. I mean, I never expected anything like this to happen. Not in a million years. How did this even happen? This is insane.
So, in the current version of Zonos, which is the very first version, you're going to need an NVIDIA graphics card, and this NVIDIA graphics card, it needs to be a 3000 series or newer. For example, the 4000 and 5000 series, like, the 3070, 4090, 5070, and so on. The developers of Zonos have mentioned that they are trying to create a version that's also compatible with AMD GPU and older graphics cards. Right now, I'm using an NVIDIA 3070 with 8 GB of RAM, and Zonos is an open-source text-to-speech project trained on 200 hours of speech in different languages. One of its best features? It's free, and it even supports emotions and expressions. That means you can add emotions to the voice. This project is licensed under Apache version 2, so you can use it in any type of video you want. The majority of the dataset for this model is in English, but it also includes a significant amount of audio in Chinese, Japanese, French, Spanish, and German. But what about other languages? Well, when you pass a word to the model, and that word isn't in the dataset, like if you try to input an Arabic word, since the dataset doesn't recognize Arabic speech, a situation occurs called OOD, or out of distribution. In cases where the model has no idea how to generate a word, Zonos tries to create it using other methods, but most likely, the quality of that word won't be very good. Now let's move on to the installation. Installing it on Windows is really simple. By default, the first version runs on Linux, and setting it up there is actually quite easy. However, a kind developer has created a Windows-compatible version, making the installation process much more convenient for us. The first thing you need to do for installation is copy this text. Then, open PowerShell with administrator privileges and paste the command there. Here, type A and press Enter. Then close this window. And next you need to download NVIDIA CUDA. Downloading it is really simple. Just go to this address, select Windows x86 in your Windows version, then click here and download the file. After downloading the file, install it. Once you've completed these two steps, you can move on to the Zonos installation process. All you need to do is click here and download the project. After downloading, extract it anywhere you prefer. Keep in mind that the models this project downloads can take up to 14 GB of storage. After extracting the files, you'll see several files in the folder. To install it, simply right-click on the installation file and select Run with PowerShell. If you don't see the Run with PowerShell option, just open PowerShell manually, type CDs, and then paste the folder address. Then, press Enter to navigate to that directory. Now type 1, press the Tab key, and then hit Enter. This will start the installation process. The installation time depends on your internet speed, so it may vary. Once the installation is complete, you'll see Install Finished at the bottom. Alright, Zonos is now installed, so how do we run it? You'll find a file named run-gradio. Just right-click on it and select Run with PowerShell. If that option doesn't appear, simply open PowerShell manually, type CDs, and paste the folder address.
Since I'm using a drive other than C, I need to type the drive letter, add a colon, and press enter. Then I type CD, right-click to paste the Zonos folder address, and hit enter again. Just type number 2, hit tab, and then press enter. Whether you do this manually or just right-click and select Run with PowerShell, it works the same way. After a few moments, Zonos will launch. Welcome to the Zonos interface. The first time you open it, you'll see this screen. Here, when you click, you'll notice 2 model options. Each model is about 3 GB in size, so if you want to use one, you'll need to download 3 GB of data. On the first launch, Zonos will automatically start downloading some essential models, and these files must be downloaded. You can track the download progress inside the CAMAD window that opened. I recommend downloading both models because later in this tutorial, I'll explain the differences between them and which one is better. Once all the required files for Zonos are downloaded, we'll move on. I'll show you how to generate the best possible voice output, add emotions to the voice, work with different voices, improve the audio quality, and cover all the details you need to know. By default, the hybrid model is selected. There are 2 models available, Transformer and Hybrid. First, I'll show you how to work with Hybrid, and then I'll explain Transformer. First, let me give you a quick overview of the Zonos interface. This section is where you enter your text. Here, you select your language. Many languages are available, but only a few, the ones I mentioned earlier, have good quality. This section is not very useful. Any sound you add here will only be placed at the beginning of the generated audio, but won't affect future outputs. This is the reference voice section. If you want the generated voice to match your tone or sound like someone else, you provide a 10 to 13 second sample. The model will try to mimic it. If your reference voice has noise, you can enable this noise reduction option. Here, you'll find various settings. I'll explain them later. And here, you can select emotions, adjust settings manually, or let the model automatically handle them. This section is really important, and I'll go over it in detail soon. Now let's test it. I asked ChatGPT to generate some sample text for us. I'll paste the text here, and without changing any settings, I'll click Generate Audio. Look at this section. It shows how long it will take to generate our audio file.
It's been a fairly regular day so far. I woke up, had my usual cup of coffee, and went through my morning routine. The weather is neither too hot nor too cold, just a normal day.
As you saw, it generated a normal-sounding voice. Now let's go over some important settings. DNS-MOS. DNS-MOS is a model that enhances the clarity of English words. If you're making a YouTube tutorial, you want words to be crisp and clear, so a higher DNS-MOS score is better. But DNS-MOS is only optimized for English. It doesn't work well for other languages. Also, it reduces emotional expression in speech. If you want an emotional voice output, disable this option. So here, I'll disable DNS-MOS, so the model won't use it. Fmax. Fmax is the highest frequency the model will generate. Always set this to the maximum value for the best quality. VQ score. VQ score is another model that clarifies the generated voice. It removes noise and enhances details without being language dependent. The default value is 0.78. Just like DNS-MOS, VQ score can reduce emotions in the output. If you're creating a tutorial, keep it enabled for clarity. If you want emotions, disable it. Set it to unconditional. Since I want to add emotions in this step, I'll disable VQ score as well. Pitch standard deviation. If you've noticed, when we speak naturally, our pitch changes based on emotion. When we're sad, our voice tends to be softer and thinner. When we're angry, our voice can be deeper or sharper. This setting controls how much pitch variation is allowed in the generated voice. A lower value makes the voice more uniform and stable. A higher value allows the voice to vary more naturally in pitch. If you're creating a story where characters express emotions, you can set this to unconditional, so the AI decides how much to adjust the pitch based on the context. So basically, this adjusts how flexible the pitch is in your generated voice.
Speaking rate. This controls the number of phonetic units spoken per second. The default is 15 and will only change it if necessary. Do not set this to unconditional, because it often makes the voice sound unnatural. Now, I want to generate a voice with an angry tone. I'll copy the text and paste it here. Look, I uncheck the emotion option because I don't want to leave it up to the AI to automatically determine emotions. Instead, I want to manually adjust the settings myself. So I'll lower the happiness value and increase the anger value. There's also an option here called CFG scale. CFG scale determines how strictly the model follows the settings we've applied. The higher we set this value, the more forcefully the model adheres to our chosen settings. Since I want the emotions to be precisely controlled and accurately expressed, I'll set this to a high value. Finally, I'll click Generate, and the voice will be produced.
As you saw, it generated a great voice, and you could clearly hear the anger in it. Now, here's something interesting. I didn't provide it with any reference voice, so it randomly picked one on its own. However, if you have a specific voice in mind, you can upload that voice, and the model will use it as a reference. For example, I'll upload a 41-second clip of my own voice, but since that's too long, I'll trim it down to about 10 to 13 seconds, which is enough. To do that, click on the scissors icon, select the part you want, click Trim. Now if I click Generate, the model will generate the output using my reference voice. What if I want to keep a randomly generated voice? If I leave the speaker setting as unconditional, the model will ignore the reference voice and randomly choose a new one. But let's say you like the randomly chosen voice and want all future outputs to sound exactly like it. What should you do? Simply download that voice and then re-upload it as the reference voice. From this point on, all generated voices will sound the same as this one. Since the randomly chosen voice is only 12 seconds long, there's no need to trim it. Now, let's test this and see if it actually works.
Are you serious right now? After everything I've done, this is what I get.
As you saw, the model generated the same voice again. Now, if I set the speaker to unconditional, it will randomly pick a new voice again. Let's create a happy voice this time. For the AI model to fully cooperate with your settings, your text should match the emotion you're aiming for. For example, if you set happiness to the max but provide an angry text, the result might be contradictory and not sound quite right. Use a happy text. Max out the happiness setting, reduce anger, add a bit of surprise. You'll need to experiment a little by tweaking these values to find the perfect balance. Since the AI model isn't 100% deterministic, you might need to click Generate a few times to get the best output.
Wow! I can't believe this is actually happening! After all the hard work and patience, we finally made it. Everything feels so perfect right now.
After 2 tries, I finally got a great, happy-sounding voice. Now, you might have noticed that each time you click Generate, the output slightly changes. This happens because of a setting called Random Seed. If Random Seed is enabled, the AI chooses a different path each time, creating slightly different results. If Random Seed is fixed, the AI follows the same pattern every time, meaning the results will be more consistent. So, if you want each generated voice to sound unique, make sure Random Seed is enabled.
Now, I want to use a reference voice to ensure the output remains consistent every time. I select about 13 seconds from the reference audio, click on Trim, and then hit Generate to create the new voice. Wow, I can't believe this is actually happening. After all the hard work and patience, we finally made it. Everything feels so perfect right now.
As you saw, the output was relatively good. By generating the audio multiple times, you can achieve the best result. Now I want to explain what the transformer model is. I'll disable the current model and select the transformer model. It takes a moment to load. The hybrid model consists of multiple models. It includes a transformer model and another model that improves output speed and reduces memory usage. However, the transformer model, especially for outputs with emotions applied, provides better quality. Why is that? I'll explain. To understand the difference between the transformer and hybrid models, look here. In the transformer model, the text is divided into different segments. For example, imagine this structure. Then, it starts processing each part separately. When it processes wow and generates an output, it examines its relationship with all other sections and generates an output accordingly. For every other section, it does the same. It checks how each word relates to the entire text and produces an output based on that. What's the benefit of this? Suppose you have an angry dialogue. With this approach, the anger is evenly distributed across all sections of the paragraph, making the emotional expression feel more natural in the sentence. What's the drawback? Now, instead of just one paragraph, imagine processing 10 paragraphs. If the input is large, every time a section is processed, the entire text needs to be analyzed. This requires more memory and time. How does the hybrid model work? The hybrid model uses an architecture called SSM, State Space Model.
The SSM state space model has a memory. It starts processing the text from the beginning and stores its interpretation of the text in this memory. For example, different emotions, tone of voice, and other elements. Then, it moves on to the next part of the text, processes it, and updates the memory again. For instance, it might recognize that the tone has become angrier. Next, it continues processing the following part of the text using the stored memory. If it detects a shift in emotion, like the speaker becoming happier, it updates the memory accordingly. It keeps going like this, processing each segment while using and updating its memory instead of reanalyzing the entire text repeatedly. This way, it generates an output while relying on the stored information, leading to reduced processing time and faster performance. So, what's the takeaway? If you want to generate an emotionally expressive sentence with smoother and more natural emotional transitions, I recommend using the transformer model. If you're creating an educational video, the hybrid model is a better choice. The hybrid model can still handle emotions reasonably well, but in my opinion, the transformer model is more suitable for that purpose. All right, now let's generate the same sentence using the transformer model. Notice that when we switch to transformer, there are fewer conditional parameters available. I want the pitch to be adjusted automatically, so I enable this option and click on Generate to see what kind of output we get.
Wow! I can't believe this is actually happening. After all the hard work and patience, we finally made it. Everyone is smiling, and I just can't stop feeling this incredible excitement. Wow, I can't believe this is actually happening. After all the hard work and patience, we finally made it. Everything feels so perfect right now. The sun is shining, everyone is smiling, and I just can't stop feeling this incredible excitement. Wow, I can't believe this is actually happening. After all the hard work and patience, we finally made it. Everything feels so perfect right now. The sun is shining, everyone is smiling, and I just can't stop feeling this incredible excitement. As you saw, the output quality was really good. I recommend that if you want to better convey emotions, you should enable speaking rate and Fmax as well. This allows the AI to fully utilize different parts of its model for better results. Also, to make sure the output captures the intended emotion, your text and punctuation are crucial. For example, if I add a few laughs and an exclamation mark, the happiness might be conveyed better. I'll check this option and click Generate again.
Wow, I can't believe this is actually happening. After all the hard work and patience, we finally made it. Everything feels so perfect right now. The sun is shining, everyone is smiling, and
Now, as you saw, the non-referenced voice output was really good. The happiness was clearly noticeable, but for professional work, we need reference voices. That's why it's essential to experiment with these settings and generate multiple outputs until we get the exact reference voice we want. However, if that doesn't work, you can generate an output without a reference voice and then use RVC software to convert it to the desired voice. I've already posted a full tutorial on RVC, so you can check it out for more details.
Wow, I can't believe this is actually happening. Ha 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 ha. After all the hard work and
Overall, not bad. But keep in mind that sometimes the reference voice might reduce the emotional expressiveness in the output.
Now, if I set this to unconditional, meaning I make the speaker unconditional, I'm basically telling the model that it doesn't need to use my preset voice model. Then, when I click Generate Audio, there's a high chance that the emotion in the output will be conveyed much more effectively.
Wow, I can't believe this is actually happening. After all the hard work and patience, we finally made it. Everything feels so perfect right now. The sun is shining.
As you saw, the emotion in the output was conveyed really well. I think I've covered everything about this AI. There's nothing left. But if you have any questions, feel free to ask in the comments. I think I forgot to mention the min-p parameter. So, when the model generates audio, it predicts multiple possible outputs. For example, let's say 10 different variations, based on the formulas and context. Then, it assigns a probability to each one. With min-p, you're telling the model not to choose any option with a probability lower than this value. If you lower this setting, the output will be more creative, but it might not always sound good. If you increase it, the output becomes more stable and consistent. I recommend keeping it at its default value, but the most important thing is to experiment. Try adjusting different parameters, tweaking the values, and doing some trial and error to get the best possible output. It's not always as simple as setting happiness to 1 and everything else to 0 to create a happy voice. For example, you could increase surprise, adjust other, or lower disgust to see if that gives you a better result. Oh, and one more tip. If you're creating an educational narration, I suggest disabling speaking rate, disabling pitch SCD, keeping min-p at its default value, turning off Fmax, setting this to max, using a reference speaker voice, keeping everything at a standard value, increasing this option for a neutral tone. For educational content without emotions, I recommend using hybrid mode. Hope this helps. Make sure to follow our page because we're committed to providing the best tutorials with the highest quality. Goodbye.